Hello ECON 2040, this is Janelle Mann and I am wrapping up the remainder of the course content in this video. First, let's connect the least squares regression line with the population regression line. The population regression line is written here at the top of the slide. You can see I have denoted the population parameters using Greek letters. We have beta 0, beta 1, and sigma, which are circled in green. Below, you can see the least squares regression line that we estimate using a sample. B0 is used to estimate beta 0. B1 is used to estimate beta 1. And finally, we have the disturbance term, which is normally distributed with a mean of 0 and a standard deviation of sigma. Sigma is our third population parameter. We use the residuals to calculate the estimate for the standard deviation of the disturbance. You can see down here, I wrote the formula for the residuals. For each residual, EI is equal to the actual value, YI, subtract YI hat, which is the predicted value. In order to calculate an estimate for the standard deviation, we take each of these residuals, we square them, add them up, and divide them by n minus 2. This gives us s squared. If we take the square root of s squared, it is the standard deviation estimate. So some people call the standard deviation the standard error, and that's what Gretel calls it. So this is the square root of s squared equal to the standard error of beta 1. So now let's use this information to perform some inferences about the population. So this is connecting chapter 7, all the information learned there, now with our chapter 10, which is inference about the regression model. So first of all, we're going to calculate a 95% confidence interval. This formula is very similar to the confidence intervals that we've calculated so far. So we have B1 plus or minus T star multiplied by the standard error for B1. We need to make sure that we calculate T star using n minus 2 degrees of freedom. So now let's look at our information here to perform the calculations. So we're going to start with the lower bound. So we take B1, subtract our T star. So let's think about the T star for a moment. I gave you 4 different Gretel outputs to select from. We are using a 95% confidence interval, and that means in each tail 0.025 or 2.5% of the area lies. So that is this screen right here or this screen right here. The ones at the bottom would be for a 90% confidence interval. The next thing we need to think about is the degrees of freedom. We have 436 observations. The degrees of freedom is n minus 2, which gives us 434 degrees of freedom. So now we have our critical value. And we multiply that by the standard error of B1. We can get that from the Gretel output up here. And now we can have our calculation for the lower bound complete, which is negative 0.03042. Conduct the same thing for the upper bound, which you just change the subtract sign to an addition sign, and we have now the full confidence interval. What this tells us is that for a 1 unit increase in miles per gallon on the highway, CO2 emissions go down between 2.915 and 3.042%. Now, moving on. We now want to fill in T. This is this black space here that I intentionally blocked. This calculation is so very close to that in Chapter 7. We don't need to spend too much time here. So if you remember, this is Chapter 7. Our t-statistic was x bar subtract mu divided by the standard error of x bar. Now we have b1 subtract beta 1 divided by the standard error of b1. First of all, what we need to know is what is this t-ratio actually testing? And every single output, no matter whether you're using Gretel or Stata or really any other output, will always give you the hypothesis test that is two-sided, where b1 is equal to 0 against the alternative that beta 1 is not equal to 0. So it is a two-sided test. So let's conduct this test. So our first step is always the hypothesis. Our next step is calculating t. So to calculate t, we have the estimate for beta 1, subtract what we are actually testing, against 0 in this case, divided by the standard error of b1. When you calculate that out, you'll find the value of negative 91.806. This is a very extreme value for t, and even without looking at the tables or calculating the p-value, we know that we are going to reject the hypothesis, the null hypothesis. But just to make things follow the same pattern as before, the next thing that we did is we would calculate the critical value and place it on the distribution. So again, in this case, we have 434 degrees of freedom. We are performing a two-sided test. So we need to pick an alpha level. We could pick whichever alpha level we want. It doesn't matter to me. But just to be consistent with the previous one, let's do alpha is equal to 5% because we used a 95% confidence interval in the previous one. So here we are. We have our critical value, 1.96545. So I place that here on the distribution. Since our distribution, we only go down to -3. Already the probability is very small at -3. But if we were to plot -91, it would be way over here. So thinking about our football example, we have our field goals out here. We would reject our field goal over here. It's two-sided. We also reject. You would not get any points for the field goal in that case. So that leads us to our conclusion, which is step 4. We reject the null hypothesis and conclude that beta 1 is statistically significant at any reasonable level of significance because the p-value is 1.93 times 10 to the negative 286, which I got from up here. Or you could write that with respect to the critical value. So you could also say we reject the null hypothesis and conclude beta 1 is statistically significant because the calculated t-statistic is negative 91.806, which is less than the lower critical value, which is negative 1.96545. So finally, I just wanted to wrap up the class now. I know I showed a few of you this before, but this is a famous quote from a superhero, from his uncle, and it says, "With great power, there must also come great responsibility." So of course, we are not superheroes finishing up this course, but we have covered tools that can be used to aid decision-making in many different organizations. So you can look at nonprofit, you can look at government, you can look at businesses, large businesses, small businesses, but this is my caution to you is we have these tools that can be very powerful, but we need to be extra diligent and careful in how we use the tools, because if you misuse the tools, you will result in the incorrect decision, and that is not any better. In fact, it might even be worse than just using your gut instinct to make a decision.